a die is rolled twice, what is the probability of rolling a 5 first, followed by rolling an even number? So there's definitely like two events going on, and we want to know the probability of the first event and the second event. So we do want to use that and equation. So it's the probability of event A and the probability of event B occurring. Now, if these are independent, the probability of A will the probability of B is not affected by the probability of A, then it's just our answer here is just the probability of A, the first event happening, times the probability of the second event happening, call it B. So our A is rolling a 5 first, and our B, the event B, is rolling an even number. So we have to ask ourselves, are those independent? In other words, does the probability of, when we go to roll the die the second time, does the probability of us getting an even number change based on the fact that we got to roll a 5 when we rolled the first time? And the answer is no. Our probability of us getting an even number is not going to change. So you can just go ahead and use this formula. Probability of A rolling a 5 is, so you're talking about a 6-sided dice with all the numbers between 1 and 6 on the sides. Well, 5 is only one of the 6 sides there on that dice. So that's why probability of rolling a 5 is a 1 out of 6. Then the probability of rolling an even number, well, there's 3, because on a dice, there's the numbers 1, 2, 3, 4, 5, and 6. They're written as dots on the dice, and 3 of those are even, right? So the 2, 4, and 6. So 3 out of the 6, we have a probability of 3 out of 6 getting an even number. So we just multiply those numbers together, and you multiply straight across 1 times 3, which is 3, and then 6 times 6, which is 36. And then reduce that, to make sure to reduce that. And the way I always reduce fractions is I pick the smaller number, whether it's in the numerator or denominator, I take the smaller number and I prime factor that number. So 3 is already a prime. I can't write it as another number times by itself other than 3 and 1. So 3 is prime. So I just have to make sure that 3 doesn't divide into 36. And if 3 doesn't divide into 36, then it's completely reduced. But 3 does go into 36. So divide the top and bottom by 3. And I get 1 over 12. And there we go. That was your final answer. Do make sure that you did reduce your fraction completely. I think that's the error in this problem. It could throw people off. All right.